Assalamualaikum and a very good afternoon to all panels and judges. Um, Today I would like to present our product with the title Desktop Application Based Malay Language Vowel Classification for Stroke Patient Rehabilitation Assessment. So I'm the presenter for today, Nick Muhammad Zarifi bin Hashim from University Technical Malaysia Melaka with my colleagues Shahmina and Juzaila, with our partner from the Perkeso Rehab, Afika, and uh, Nick Adila from Unimap. So first of all, I would like to introduce our project is all about. So in recent years, the silent killer disease, defined as a non-communicable disease (NCD), has become a frequent topic discussed in everywhere, especially in the academic lines, conferences, and so on. So if you take a look at the graph on the bottom left, we can see that the rising of the non-commutable disease cases from 10 years, approximate 10 years back to the 2020 to 2020 was drastically rise up compared to the others, the commutable disease and injuries. So for this reason, basically rehab is one of the method to train back the ability that been taken away or lost by the one of the silent killer disease, what we call it stroke. Okay, so for this particular viewpoint, we face several problems regards to the stroke patient. So in order to have a good rehab activities and procedure, basically we need to have a good data sets and the a good analysis software in order to provide a good systematic assessment for the patient. So speaking of those, regional sound analysis is happen in the Southeast Asia. We can see the research conducted uh, was likely a group for the Malay speaker region, Vietnamese, Thailand, Indian, and Bangla, and so on and so forth. Okay, so plus speaking of this, basically we find that the most critical problem is to have a good data set in order to have a good analysis for distribution. So for this, before we go to a smart system, what we call it rehabilitation system, basically we need to have an image via the deep learning. So perhaps speaking of the image from sound is kind of weird from the starting point what we did 2019 over here. So that would be the problem that we face. For that particular problem, we come up with the innovation objective. So first of all, we basically we try to convert our sound images on the top to the visible, what we call image profile for each particular recorded sound. So this is recorded one. This is the one that we transformed from the sound wave to the image file. So the second one is to build a smart vowel classification for stroke patient assessment via the deep learning. So this is the one of the example of neural network that has been widely used in the whole world. And the last objective is to design a graphical user interface for the vowel classification. Basically, when we when we record the file of sound over here, so the sound basically will be transformed by pressing this wave to image. And lastly, after we press the classification button, basically we will notify what is the sound will be classified, either A, I, U, E, or O. Okay. So from the beginning, 2019 and the end slightly, before the pandemic came over. So basically what we did is we start our journey with the lowest level, because at this current point, basically we achieve the TRL level number 5, whereby the production enhancement technology model has been fulfilled over here. So far two years back time, basically we did start with TRL3 classification model conducted in lab using only a healthy person voices sample. So these are the voices of by the healthy person recorded after transferring to the image file. So and then in the end of 2020 and the beginning of 2021, basically we success to get the voice from the patient. So basically we transfer that sound to be as an image. So then recently in 2022, I think first quarter, basically we um, success to publish one journal. So basically the TRL5 is combination of the healthy images from the sound of a healthy person plus the sound from the patient stroke patient voices. So that would be enlargement from the TL3, 4, and finally we have this currently. Okay, speaking of which, innovation product impact. So we believe that if our product can be accelerate forward, I mean to the national level or to the world level, basically these are what we can give to the community. So first of all, is 94% of smart vowel classification accuracy happen to be trained, tested, and evaluated by ourselves in the lab environment and the TRL level environment. So we can this project can be implemented without the presence of SSL. So we believe that without this system, basically the traditional way to assess the one stroke patient is via the presence of SSL at the rehab center. Okay. So and again, based on the standard neural network, which has been presented just now, we utilize VG16. Basically, the results are reliable because the more image that you have, the good classification or the brain of the system that we could achieve. So regarding to this, so the traditional way of assessing, basically it depends on the hearing, a level of assessor. So whereby we can understand that some of the people with less hearing capability will assess a wrongly decision for the rehab um, assessment for the one particular patient. So plus by having these apps in the desktop, embedded in the desktop, we can go nearly everywhere. It's not really depends on the location of the assessor itself. Okay. So last but not least, basically we this is the feature will be coming soon to the what we have in our system right now, become 2.0 version. So systematic storage assessment record for having the full report of several sessions conducted. And yeah, paperless, basically we will have the tendency of the result project for, let's say, we given an R a sound. Basically, what is the percentage similarity between the given R to R, E, U, A, O? Then we have a graph over the apps itself. Okay, where can the product be used is basically the apps or the product. Basically, we can extend it and we can give accelerate to all the researchers all around the nation and around the world who utilize the deep learning for the research development. Obviously, a stroke patient vowel voice rehabilitation and training assessment is basically the one that most probably accurate application or uses for our product. So syllabus and okay, in this particular products, basically we assess the vowel itself in the language. We have vowel, syllabus, terms, and sentences. So now, in the current product that we have, we go to the vowel because of this, for the sake of the stroke patient. So whereby the syllabus and the terms or even full sentence is basically our prospect in the future for the how to say, for the kindergarten and Tadika and Tabika kids to keep it up the pronunciation on the Malay language during their playing time. So this product could be applied in future via mobile phone, and obviously, as I mentioned before, patient data management also could be extended, while self-assessment also could be realized once we do have mobile apps embedded in our mobile phones. So our proposed project is basically having a several authenticity and novelty. So back to the 2019 when we started our research, basically the idea and the what we call it the gear one has been started, but at a particular time, the how to say the acceptance of Perkeso and all the collaborators that we did discuss with them is kind of how to say cannot be cannot cannot be understandable kind of concept. So because that would be difficult, and is it possible kind of question came over to us, but we just stick in our mind that we proceed to the front. So then it's kind of how to say I just give it a smile to myself when I noticed that Google is basically publicly introduced their teachable machine, whereby the teachable machine is basically converted to sound to the image, which is available publicly in their website, I think end of last year. So yeah, so that would be Google is a good company though. And then the second novelty is Malay vowel datasets. The one that we have is Malay language. I mean, it could be utilized in Indonesia, Brunei, and Singapore. So then we have the mix between patient and healthy voices in our Hasim dataset. So this combination of dataset basically has been submitted as our copyright in early 2020. So waiting for the MIPO number, and yeah, we will officially get the our copyright soon. So speaking of the potential in commercialization and so on, so currently since we have um, a good relation with Perkiso, we are looking forward to have a good connection too with Kementerian Kesihatan Malaysia and other rehab center in order to have the a wide potential market or to commercialize our product. So currently we have one LOI and also MOU between UTEM and Perkeso in the whole at this side of the view. So technically we are looking forward to sell our product in 2023 to Perkeso approximate 30,000, whereby the copyright is cost 10,000, the project itself, the whole concept and so on is 10,000, and the cost for the R&D is also 10,000 approximate. So whereby this particular R&D cost is refer to the manpower of the research collaborator and so on. Okay, about the intellectual property, we managed to get the one copyright as I mentioned before. This is the members of the copyright gained by our group. They call it HASIM. And yeah, we also successfully submitted one. This one is the first one, 2021. The earliest our research result in IEEE conference happened in Turkey conference, and then followed by this is the journal from WAS, and followed by this one is the Scopus journal, which published in March, it's not May 2022, and this one is the recently presented in ETIC, which happened in University Malaysia Pahang, ETIC 2022. I did present virtually over here. So in total we have 4 publication, academic publication over here. So I think with that, thank you for my presentation, and hope our product will be go to the finalists. Thank you.